This video will provide a brief introduction to lists and dictionaries in Python. They have many similarities and differences, but notably they are both flexible and powerful containers for data in Python. Now, while they can be used on their own, they're often used in conjunction with arrays and data frames, so those larger data structures we discussed in the previous video. And therefore, understanding the fundamentals of how they work and how you might modify them is a really important foundational skill for anyone pursuing machine learning projects and work in Python. We'll start by discussing lists. They're slightly simpler and they'll be familiar to you coming from MATLAB. A single component of a list is called an element. So whenever I refer to an element in future slides and future videos, that's what we're talking about. Now, as we talk about indexing, the first point that I'll make that's very important across the board in Python is that indexing starts at 0 and not at 1. So if you want to pull the first element of a list, you are using the index 0 and not the index 1. I've put some examples on the screen of how you might index a list. So if you want to pull one value out of a list, you'll use its index. The first value, like we discussed, can be pulled by writing the name of the list, followed immediately by 0 in square brackets. So 0 is the first element, but you can replace that with any index you want to pull a value at any point in a list. As well, if you want to pull the last element of a list, you can write -1 in the spot where you would put an index value, and that will pull the last element of the list. If you want to pull the second last element, you just write -2 instead of -1. And the example that I've given you here, we're assigning a name or a variable to that value. So for the first, we write first equals list name, blood glucose, and then in square brackets, 0, and that will create a variable that's equal to the value of the first value in our list. That makes it really easy for you to then print out that value if you want to figure out what it is, and that's the example that I have in front of you here. You can also slice lists. So as opposed to just taking one element, you can take a slice of elements, so multiple elements. And the way that we do that is using the start::stop language. So the start would be the first index and the stop would be the last index of the slice that you want to pull. Importantly, the start is inclusive. So if you write 1, you're going to get the element as part of the slice at index 1. Whereas for stop, it's exclusive. So if you write the index 5 there, you're going to get everything up until the 4th, or the element at index equals 4, not index equals 5. You can also use this language if you want to pull the first 2 elements or the last 2 elements. I've put those examples on the screen here. So for the first 2, you just leave the start index empty, and for the last 2, you leave the stop index empty. And you'll notice for the first 2, I've written blank:2, and that will get you everything at index 0 and 1, but not at index 2. So that's the first 2. And for the last 2, we have index 4 and 5, and it goes until the end. So anything from index 4 onward is what we're asking for here. You can also modify lists, as we've discussed. For example, you can append. This would be adding a certain value to the list, and you can sort. That would be sorting the values in ascending order is the kind of default sorting mechanism. There are many other things you can do with lists. I encourage you to look up other functions that you might apply. Maybe you want to sort in descending instead of ascending order. How would you do that? Look into it, do some research. Next, we'll talk about dictionaries. Now, as I said, dictionaries have some similarities to lists and some differences. What is very noticeable, just looking at the example on the screen, is that for every element of a dictionary, we have a key and we have a value, which are separated by a colon. So the key is what you use to look up a certain value. As an example, we have patient IDs and their associated blood glucose. So I might want to know, what is the blood glucose of patient 479? I could look them up using that key and I would find that they have a blood glucose of 5. So instead of looking up a value using its index, you look up a value using its key. There are many use cases for dictionaries. You'll find yourself working with them in a lot of different realms of machine learning on Python. Because we haven't gotten into a lot of the larger data structures and machine learning algorithms. It will be hard for me to give you a lot of those examples. It's just important to know how to work with dictionaries for right now and be familiar with them when they come up in the future. First example of how you could use a dictionary is to store or organize data. So if you want to save one patient's data in a dictionary, you can do it like we have on the screen here, age, BMI, blood pressure, and whether or not they have diabetes. And then if you want to find, as we said, a certain value, perhaps the patient's BMI, you simply write the name of the dictionary followed by, in square brackets, the key for the value that you want to print. And that's what we've done here to find the patient's BMI. You can also use dictionaries for label encoding. So sometimes you might have a list like we do here of string values. And while that is very informative for us, an algorithm is not going to be able to differentiate between different strings. It's only going to want to work with numerical data a lot of the time. So often what we have to do is what's called label encoding, where we take a string value and we encode it with a certain numerical value. So as an example here, we have whether or not somebody has a diabetes, pre-diabetes, or a healthy diagnosis, and we'll create a dictionary so that we make sure that everyone who has a healthy diagnosis is given a value of 0, everyone with pre-diabetes is given a value of 1, and everyone with diabetes is given a value of 2. We often do this as well with presence or absence of certain features, like does somebody have a cardiovascular comorbidity or not? And then we have just a 0 and 1 kind of binary feature, which is really, really valuable in machine learning. I've written an example at the bottom of this little chunk of code of how you would actually use the dictionary to replace those values with numbers. And we use a for loop, which will be discussed in much more detail in a future video. But this is just an example of how you might use a dictionary. Now we have a challenge yourself section. I've written out a set of lists, and I'll just have you pause, open up your practice notebook, and go through each of the questions and try to answer them. And here are the answers. This is the list section. This is the dictionary section. Thanks so much.